Purpose of this video is to look at how we can correct traverses for local attraction. So we've got a traverse here. Okay, it's an open traverse, and we think there's a few errors in here. Okay, the reason why we think there's a few errors is that in some of these legs, remember this is bearing and this is back bearing. The difference between these two should be 180. Okay, however, if we do the calculation, we'll find that it's not 180. Okay, in this instance, it's 176. Okay, so there's some error involved here. We're going to try a quite specific way of seeing where this error is. So let's have a look if we can draw a rough sketch of what this looks like. So I start at point P and I go 141 degrees to point Q. So down here somewhere to point Q. And then I go 56 degrees to point R. So maybe here to point R. And then 123 degrees to point S. So this is just all a rough sketch, so we've got something to refer to. And then 14 degrees to point T. Okay, so what we used there were all the bearings. So I used 141, 56, 123, and 14 degrees. I used all of these. So what actually happens when they're making this traverse is that the person will start at P. Okay, so they start at P and get their compass out and see what direction it is to Q. Okay, and they'll write that here, walk in that direction. When they get to Q, they'll look back again with their compass and they'll write that back bearing. Okay, then they'll say, all right, now I'm going to go, to R. So from Q to R, I'll measure that bearing, I'll get to R, measure the back bearing, and measure the bearing to S. All right, so we've got a few little errors in here. Okay, some of the bearings and back bearings don't have a difference of 180. And we're going to look at why that's the case and how we can possibly fix it. So some of the issues taken with this survey are that some bearing and back bearing pairs that don't have a difference of 180. Don't differ by 180 degrees. Okay, so we know that this one didn't because it was 176 degrees. The difference between these two is 181. This one's okay. And this one's 177 degrees. Okay, so they don't differ by 180, meaning we've got some error there. Okay, so we're going to do this in a systematic way to try and correct it. All right, and basically going to do this in two sections. So we'll have the original measurements, we'll make some corrections, and then we'll have the corrected bearings. So the first step is to translate this information into, not that part of the table, this part of the table. So for the leg from P to Q, the forward bearing was 141 degrees, the back bearing was 317 degrees, and the difference between them was 176. I'll do the same thing for these other ones. From Q to R, 056, 236. Difference was 180. Okay, and I'll just finish these other ones. You can do it. All right, now comes the tricky part. So the reason why some of these bearings are incorrect is because in some of these points there could be, for example, a big set of power lines around here, okay, which would be messing up with the operation of our compass. The way the compass works, this is the Earth. I'm standing here with my compass. That little needle is going to always point north to south because the Earth is basically a big magnet. That little needle on your compass is also a magnet, and they'll align. If we've got something like power lines going through here, you know that the power line has like a magnetic force around it. It'll interfere with your magnet. What are some other things that could possibly interfere with these magnets? Someone say a big mountain. Yeah, sure. There could be a big mountain here with lots of minerals in it, essentially acting like a magnet as well, which might mess up our compass measurements at one of these particular points. And where we're going to start is look for one where there's no error. So between Q and R, we had bearing and back bearing that had a difference of 180. So the assumption that we're going to make is that it's okay at Q and okay at R. Okay, there's no power lines or no big mountains there. We'll assume that they're the same. So we don't need to make any corrections here. And we'll keep the forward bearing and back bearing exactly the same. Okay, so what that means is that if I'm assuming that Q and R are okay, then this back bearing that I took from Q to P is also okay. Okay, this back bearing is the 317. Okay, it's also okay. And it also means that the bearing I took from R to S is also okay. Okay, this 123. Okay, there's no corrections needed there because we're working under the assumption that Q and R don't have any mountains or power lines around them. So where we're at is we need to correct these bearings somehow. So we've got some error at P. Okay, I need to change this forward bearing, this 141, need to change it to something here so that there's a difference of 180. Okay, so this back bearing 317, to calculate the forward bearing, I'll subtract 180. Okay, it should have been 137 degrees. I'll write that in a different color because it's one that I've modified. Okay, which means from the original bearing to the forward bearing, I've needed to make a correction of -4 degrees. So for every measurement I make from point P, I need to subtract 4 degrees from it because my compass bearing is off. Okay, it's not pointing north; it's pointing 4 degrees to the to this direction. Okay, it's actually showing north around here. Okay, so I've corrected there. I'll do a similar thing down here with my point S, okay, because I know there's some error at point S. I've got a forward bearing, need to calculate the back bearing. I'll add 180 to it because the angle's less than 180. I'll get 303 degrees. So I've had to correct 304 to 303. I've had to subtract 1 degree. All right, what's going on? Okay, so basically everything at S, I'm going to have to subtract 1 degree from. So I subtracted 1 degree to the back bearing. I'll also have to subtract 1 degree to the bearing to T, which is my 14 degrees. So I'm going to do the same subtraction, and I'll end up with 13 degrees here. So these two cells will always be the same. Okay, 0 and 0, 0 and 0. Okay, diagonally will always be the same. Oops, I needed you guys. Go away, red circle. Okay, the only thing left to do is to calculate what the final back bearing should be. So it was 191. Wonder what it should be now. Well, I've got a forward bearing of 13 degrees. I'll add 180 to it. I should have a back bearing of 193, which means that I've had to correct by adding 2 degrees at the point T. So if there was then another leg, if I measured something from T, I'd have to add 2 degrees to whatever that bearing was. So what we've been able to do is identify that there's no local attraction at point Q or point R. A local attraction means that compass needle isn't attracted, doesn't want to move towards something mountain or some set of power lines. Okay, and we've been able to correct the traverse. Okay, so once we've got this corrected bearings table, okay, I'll use this table to draw the scale diagram of the traverse, exactly like we did in lesson 7. Okay, so have a go at these questions. If you've got any questions, make sure you ask me.